The distributed cache coherence protocol defines the mechanisms by which multiple cache instances maintain consistency across a networked system. This document describes the architecture, message types, timing constraints, and failure modes of the coherence system. The protocol operates in a fully asynchronous environment without global clock synchronization. All timestamps are logical, derived from Lamport counters maintained at each node. The cache instance represents a local data storage structure maintained by each participant node in the coherence domain. Each instance tracks a set of cache lines, where each line contains data, metadata, and coherent state. The state machine defines 4 possible states: exclusive, shared, invalid, and pending. Transitions between states occur in response to local operations and messages received from remote instances. The exclusive state indicates that a cache line is held solely by one instance and no other instance may possess a valid copy. An instance in the exclusive state may perform both read and write operations on the line without issuing coherence messages. The line remains in this state until a coherence request arrives from another instance or until the line is evicted from the local cache. The shared state permits multiple instances to maintain valid copies of a cache line simultaneously. All instances holding shared copies may perform read operations without coherence communication. Write operations are not permitted while a line remains in the shared state. An instance must first transition the line to exclusive state through a state change request directed to the coherence master. The invalid state means a cache line is no longer valid and may not be accessed by the local instance. Invalid lines occupy space in the cache but contribute no functional value. Lines transition to invalid state upon receipt of an invalidation message from the coherence protocol. The local instance must issue a fetch request to obtain the current data if access is later required. The pending state represents a transient condition during which a cache line is awaiting a response to an outstanding coherence request. Lines in pending state cannot be accessed. Attempts to access a pending line are buffered until the state transitions to either exclusive or shared. The pending state has a maximum duration equal to the configured coherence timeout interval. State transition from shared to exclusive requires transmission of a write-acquire message address to the coherence master node for that line. The master node processes the request and issues an invalidate message to all other instances holding shared copies. Those instances transition their copies to invalid state and send acknowledgement messages. The requesting instance receives the acknowledgement sequence and completes its transition. The coherence master is a distinguished node within the system designated to manage state transitions and ordering constraints for a particular cache line. Assignment of master nodes is determined by a consistent hashing function applied to the cache line address. The master maintains a list of instances holding valid copies and enforces mutual exclusion of exclusive ownership. Master assignment is static and changes only upon instance failure. The read-acquire message is transmitted by an instance that requires a valid copy of a cache line for read access only. This message is directed to the coherence master for the line. The master records the requesting instance in its list of sharers and returns a read-acquire response message containing the current valid data. The requesting instance transitions its line from invalid to shared state upon receiving the response. The invalidate message is broadcast by the coherence master when an instance has acquired exclusive ownership of a line held by others in shared state. The invalidate message contains the cache line address and a unique timestamp. Each receiving instance must transition the specified line to invalid state and send an acknowledgement response. If an instance has already evicted the line, it returns acknowledgement without action. Message delivery in the coherence protocol is guaranteed to be reliable and order-preserving within a single coherence domain. Messages addressing the same cache line follow strict causal ordering. Messages addressing different cache lines may be reordered without protocol violation. Network partitions longer than the configured timeout interval trigger failure detection and recovery procedures. Timeout values are configured globally for the entire coherence domain. The default request timeout is 30 seconds. The coherence master tracks pending requests and issues timeout responses if no acknowledgement arrives within this interval. Instances receiving timeout responses transition pending lines to invalid state and must retry their request. Excessive timeouts may indicate node failure. Cache eviction occurs when the local storage capacity is exceeded and a line must be removed to make space for new data. Lines in exclusive state may be evicted immediately without protocol notification. Lines in shared state must first be invalidated through the coherence master unless they have been unmapped from the working set. Eviction of pending lines is deferred until the pending state resolves. Crash recovery procedures activate when an instance fails unexpectedly. The coherence master detects the failure through repeated timeout of acknowledgement messages. The master then revokes all known sharers and exclusive owners associated with the failed instance. Subsequent requests for lines previously owned by the failed instance proceed normally as if the lines had been evicted. Monitoring and statistics collection is performed passively by each instance. Counters are maintained for message types transmitted and received, state transitions executed, and timeouts encountered. Statistics are accumulated in memory and may be exported upon request. No monitoring operations impact the operation of the coherence protocol or introduce measurable latency. Configuration of the coherence system is performed once at system initialization and remains fixed during normal operation. All instances must be configured with identical timeout intervals and hash functions. The list of coherence master assignments and network addresses of all participating instances must be distributed to every node before the protocol commences. Changes to configuration require full system restart.